Alright, so this is the second part of 12.4. We're looking at segments and circles. So there are two different formulas. Actually, I'm going to throw a third one out there as well. But these also, just like yesterday, you need to think about the location of the segments and the location of the vertex. So look at where they meet, where the segments meet, and that is going to tell you which formula to use. So if you notice that everything is contained inside the circle and they meet inside the circle, then the formula we're going to use is going to be part 1 times part 2 equal to part 1 times part 2. So what do I mean by that? Well, you're going to pick the parts that are on the same segment and you're going to keep them together. So if you're looking at the picture, I just highlighted it to color code it a little bit, is we would do A times C, because that's part 1 and part 2 from that green segment, equal to, then we'll do D times B, because that's part 1 and part 2 on the blue segment. So you're going to do the two parts on one segment multiplied together equal to the two parts on the other segment multiplied together. Now the ones where it's outside is where it gets a little bit trickier. So if you notice that the vertex is outside, where they meet is outside the circle, then we have to do outside times whole equal to, again, outside times whole. So what that's going to look like, this is where it gets a little bit trickier and you have to make sure you're using the right pieces, is if we were looking on the green segment of that first one. The outside part is E, but the whole thing, we actually have to add the two pieces to get that. That's going to be E times F. And then equal to, if we look at the bottom segment, I'm going to highlight that in blue, that would be the outside piece G times what this whole thing would be, which would be G plus H. So it's getting that whole that's going to be super important, because sometimes they'll give it to you drawn in, sometimes they won't. And then the bottom one actually has a special piece that I wanted to talk about. If you look at side P here, that's actually a tangent. So that one actually does have, you could use the outside times whole equals outside times whole formula, or you could use a special formula when you notice a tangent, is there's a formula that says you can just do tangent squared equal to outside times whole. But either way, if you use the outside times whole equals outside times whole, or you use the tangent formula, you actually get the same answer. Because if you look here, actually let's do the red part first. So if I did the red part first, the outside of that is P and the whole thing is also P. So that just changes to P squared, which is what the tangent squared formula says, is instead of doing outside times whole on that tangent side, you can just square it. And then for the other one, that's what's called a secant line. Let me actually define that for you up there. A secant line is a line that intersects a circle at two spots. We talked about tangent is just one intersection point. So if it intersects it at 2 points, intersects, a circle at 2 points, then we call that a secant line. So the secant lines, you do always have to do outside, which would be m, times what the whole one would be, which is m plus n, which is the same thing I'd write down here. So you have the choice of just doing outside times whole, or you can do tangent squared times whole. This will make a lot more sense if we do an actual problem, so let's jump into the problems now. So looking at number 1, first question you need to ask is where they meet. They meet inside. So for inside, we're doing part 1 times part 2 equal to part 1 times part 2. These should be the easy ones to set up. Just make sure you're keeping the ones that are on the same segment together. So if I start with this segment, that's going to be 9 times x, and then if I move to the other segment, that's going to be 12 times 15. And then we're just solving from there. This is 9x equals 180, and divide by 9, we get x equals 20. Then when we look at number 2, first question is where do they meet? Where is that corner there? That is outside the circle. So since it's outside, we should be doing x, or outside times whole, equal to outside times whole. That should be our focus right now. But if you wanted to shortcut this one actually does have, looking at it, a tangent line, is you could jump and say, oh, for tangent, instead of doing outside times whole, I can just say tangent squared. So we could do x squared equal to, then I'm going to have to do outside times whole for the secant part of that. So the outside section is 9, that's what's outside the circle. And then the whole would be what we would get if we added that all together. 9 plus 7 is 16, so I have to do 9 times 16. And then that's x squared is equal to 144. And then just make sure you're thinking about what you need to do algebraically here. To get rid of the squared, we have to take the square root, which you can just do on your calculator. You're going to hit the second and then the x squared button that's next to the 7. And that should be 12. Alright, let's try another one. Alright, number 3. Again, the first question we ask ourselves is where do they meet? These are meeting on the outside, so I know I'm going to have to do, anytime it's outside, I have to do outside times whole. So then looking at the top segment, the outside portion of that is 4. Then I have to multiply that by what the whole segment would be. Make sure to get the whole segment you're doing part plus part. Part plus part equals whole. Don't multiply them. That's a mistake sometimes that people make. So 4 plus 18 is 22. So that's outside times whole. And then I'm setting that equal to, I want to do the same thing for this other secant line. The outside part is 6 times the whole thing. Think about what you're going to do to get those two pieces together. We have to add them. So that's going to be 6 plus x. So then this here is 6 plus x. So you do have a little bit of algebra to do. 4 times 22 is 88. But then you need to distribute the 6. You get 36 plus 6x. And then we're just solving the algebra. I'm going to subtract 36. And that gives me 52 equal to 6x. And then divide by 6. And you should get x is equal to, it comes out as a decimal, 8.67. It's 8.6 repeating, which is 8.67. Alright, then let's look at number 4. So again, first question in number 4 is where do they meet? This one is inside, so since it's inside, the formula I'm thinking about is part 1 times part 2 equals part 1 times part 2. Pick a segment to start with. I'm going to start with the one that has x, so that's going to be x times 2x equal to, then we're going to look at the other segment, 8 times 9. For this one, you don't have to do any adding, you're just using the parts, because that's what the formula says to do. Just watch your algebra here. X times 2x is really going to be 2x squared, because x times x is x squared. So we get 2x squared is equal to 72. And then we just need to get the x by itself. So your first step is to divide by 2. You get x squared is equal to 36. And then again, to get rid of the squared, we're doing the square root. So we get x equals 6. Alright, we got 2 more to try. Alright, number 5. Again, the first thing I'm looking at is the location of that point where they meet. That is outside. So I know I have to do something with outside times whole. If they're both secant lines, I have to do outside times whole for both of them. But if we have a special line, look at what we've got here. We've got this special tangent line. So you can shortcut that and say, oh, instead of doing outside times whole for that particular part, I can just do tangent squared. Because that really is the outside of that red segment is 15 and the whole thing is also 15. So it's just going to turn into 15 times 15. Then I need to look at this segment, and I have to do outside times whole there. So the outside of that one is x. The whole, look at, they've already measured that for you. You don't have to do any math. You just are going to use that right away. The whole thing is 25. So we're going to fill in that the whole is 25. So anytime they have that measured out for you already, just fill that in as the whole. And now we just need to do our math here. 15 squared is 225, equal to, this is 25x, and then divide by 25. Should get x equals 9. And then the last one, I kind of want you to think about how to set this up on your own, so take a minute to do that. And now I'm going to fill it in. It should be outside times whole, because we are on the outside. That's where they meet. And then I need to fill that in for both segments. So for this top segment, the outside part is 6, and then I always like to draw this in. The whole thing is 21. So 6 times 21 for the top segment. And then for the bottom segment, the outside part is 7. The whole thing, if I draw that in, I know I have to do part plus part to get the whole, that this is going to be 7 plus x. So it's 7 times 7 plus x. And then we just got to work out the algebra. That's 126 is equal to 49 plus 7x. And then I'm subtracting 49 to get x by itself. You get 77 is equal to 7x, and divide by the 7. That means x is 11. Okay? So there are going to be, I think there's 3 problems for you to try on ClassKick, pretty much one of each type. Just to show me that you understand, please make sure you show your work. And then you have a worksheet to work on for homework. And have a great rest of your day, and check in with me on Wednesday if you guys have any questions, especially leading up to the in-class assignment at the end of the week.